Hey everybody, in this video we're going to be talking about how do we solve absolute value equations. To begin talking about how to solve absolute value equations, first let's talk about what the heck absolute value even is. What does that even mean? So let's start with the fact that the absolute value symbol is basically just two vertical lines, like two lines going up and down vertically. And all that means is that those two lines, whatever's inside of it, it just takes the value, the absolute value of that number, regardless of the sign. Meaning like that the negative sign is completely ignored. We just want to figure out what is the value, the absolute value of that number, regardless of whether it's positive or negative. So it is so absolute value, like I just explained, two vertical lines representing the magnitude or value of a number without negative signs. So the way that I like to think about it, I like to think about it in the analogy of a shower. So let's say, for example, someone is taking a shower, right? So if they're in the shower, someone's taking a shower in there, and someone goes in clean or dirty, then no matter what the case may be, they're going to come out clean. So, for example, if someone's in there and if they go in dirty, they come out clean. If they go in clean into the shower and they take a shower, but they were already clean to begin with, then no matter what, they come out clean. The same way an absolute value symbol works in very similar manner, except that instead of looking at clean or dirty, we're looking at actual numbers itself. So, for example, if you have a number that is a negative number, so like -5, the absolute value of that -5 will be just 5, because the absolute value symbols clean it or gets rid of the negative. Same way with +5. If you have a 5 that's positive or it's already positive or already clean, no matter what, it comes out clean or positive. So I like using the shower analogy because it kind of looks like two vertical doors, kind of like in a shower. So there you go. So you have the analogy. Now, what are we going to do with it? So I'm going to remind you of something that we've done in the past that some of you guys hate it, but there's a reason for my madness. There's a reason why we did it. It is how do we solve literal equations? So let's say we have, and if you're wondering what the heck I just said, what are literal equations? When we were solving for emojis, essentially, right? So we were solving for some equations in terms of variables or in terms of emojis. That's exactly what we're talking about, getting some stuff by itself. So let's say we have three examples. One of my examples is going to be 5 times happy face is equal to 10. Another example is going to be 3 times happy face plus 15 is equal to 21. And then another example, I'll have 1 over 2 multiplied by a happy face plus 3 is equal to 23. Now, the whole point of this is me getting the happy face by itself. So let's say out of all these three examples, my main objective, MO, is to get the happy face by itself. So on the left-hand side, we already learned this, so this is just a recap. I would draw the wall. I want to get the happy face alone, so the 5 is in the way. I divide both sides by 5. This cancels out, so then I get that my happy face is equal to the value of 2. So there's my answer. Happy face equals 2. On the second example, same idea, but this time I have to get rid of whatever's furthest away from the happy face. 3 is next to the happy face, so the first thing I need to get rid of is a 15. Opposite of positive 15 is negative 15, so I'm going to do that to both sides, as in subtract 15 to both sides. On the left-hand side, this cancels. I'm only left with 3 and the happy face. I just dropped that down. On the right-hand side, I have 21 minus 15, which gives me 6. So that's positive 6. Then on the next step, I want to get rid of the 3 now. It's in the way. 3 is multiplied by the happy face. Even though they don't put the dot there, assume that the dot is there. It's multiplication. So therefore, to get rid of, we have to divide it. Whatever I do to one side, I have to do it to the other side. So therefore, my final answer for this, happy face, is equal to 2. Again, same thing. Last one, same idea, right? I want to get rid of this happy face. The only difference between this problem and the last one is that we have a fraction now. So let's see how we deal with the fraction. So I would draw the vertical wall or the line. The opposite of positive 3 is negative 3. Same thing, I start with the 3 in this case because the 1/2 is next to the happy face. So we always start with whatever's furthest away first. This cancels out. 23 minus 3 is just 20. And now I have to cancel out or get rid of the 1/2. So if I want to get rid of the 1/2 and I want to cancel it, the opposite of 1/2, or the multiplicative inverse, hint, hint, something we've done in the past, is to multiply by 2. So the multiplicative inverse of 1/2 is 2, multiplied by 2. Whatever I do to one side, I have to do it to the other side by the properties of equality. This cancels out. I'm left with 1 times the happy face, which is just happy face, right? So that everything goes away there, which is what I want. 20 times 2 would give me a value of 40. So my happy face for the last little quick example that I made up is 40. Now, this is all going to come into play in a minute because you're not going to really learn anything that you haven't learned in the past. All you're going to be doing is learning the steps for how do we solve absolute value equations. Everything else you already know. So, step 1, first thing you need to do is isolate the absolute value braces. The same thing that we just did with the happy faces, as in get the happy face by itself, we're going to be doing the same thing with the absolute value braces, right? That's absolute first step. Get the absolute value symbol by itself. Then, second step, verify that the equation is valid, meaning that verify that you could actually solve that equation. What that means by that is, can you take the absolute value of a number, let's say, for example, negative 10, could that be anything besides positive 10? The answer is no, right? The answer for that would be it can only be positive 10. I cannot take the absolute value of something and get a negative answer. So that's what I mean by verify it. So like, for example, if you have the absolute value of x, if that's equal to negative 5, that is not true because whenever you take the absolute value of something, you always get a positive number, never a negative number. So if you get a negative number, then it's invalid, meaning that you're not going to have a solution. You can't solve it. So we'll do some examples of that. Step 3, remove the braces by splitting into 2 separate equations, positive version and negative version, but you're only changing the number. We're not changing the equation, right? And then we'll do some examples in a bit. And then we just solve the equation, each one. Most likely you will get 2 answers. Every time you're solving absolute value equations, you're probably going to get 2 answers, with one minor exception, and you'll figure out that exception yourself once you do some problems. Okay, so example number 1, solve the equation for the indicated variable. All right, so as you know, the first thing we need to do is, same thing with the happy face, get the absolute value symbol by itself. The good thing about this example is that the absolute value symbol is already by itself, so we don't need to worry about that anymore. Next thing we need to do, in order for us to be able to get rid of the absolute value braces, step 2 says verify that the equation is valid. So can I take the absolute value of something and get a positive number? Yeah, absolutely, right? Absolute value gives you positive numbers no matter what. So yeah, that equation is definitely valid. So move on to step 3. Step 3 says remove the braces by splitting into 2 separate equations, positive and positive and negative. Only change the number, not the equation. Okay, what that means is that now I can split it into 2 equations, positive version and negative version, but I'm only going to be changing the number, not the stuff on the inside of the equation. So I'm going to rewrite this twice. I'm going to first rewrite this as 9 plus 4x, and I'm going to set it equal to positive 1. And then I'm going to rewrite it again, second equation, 9 plus 4x, and I'm going to write this equal to negative 1. So in order for us to get rid of the absolute value symbol, we have to account for every possible scenario. One of the scenarios is in which the equation is positive, or the value of the inside would be positive. And another one would be in the case in which it is negative. So we just accounted for both equations, and now we basically just have to solve each one, and then we're done. Okay, so let's solve it. So we draw the wall. We subtract 9 on both sides, subtract 9, subtract 9. You've done this a million times by now, so I'm going to go a little bit quick. 1 minus 9 will give you negative 8. Divide by 4 on both sides, divide by 4, divide by 4. I get x is equal to negative 2. Boom, you have one of the answers. On the right-hand side, same thing. I draw the wall, subtract 9, subtract 9. In this case, we have a negative 1 minus 9. Since they're both negative, we're going to have to add them. And the answer remains negative, so we get a negative 10. I divide by 4 on both sides, divide by 4, divide by 4. In this case, I get a fraction. Who cares? You can leave it as a fraction. The only thing we can do is simplify. And by that, I mean you can divide top and bottom by 2. Ooh, that's ugly. Let me make that nicer. So the top and bottom, I can divide this by 2 and by 2. And then I get my final answer, which again, I prefer it if you just leave it as a fraction. I don't really care too much about decimals. Even though if you had a calculator, you can convert it into decimal, but you can leave it as an improper fraction. So the answer is x is equal to negative 5 over 2. Okay, so example number 2. That's it. Same idea. Like I said, you're not going to learn anything new except for the steps. Solve the equation for the indicated variable, which means you have to solve the absolute value equation. So first thing we need to do is get the absolute value symbol by itself. The question is the absolute value symbol by itself now? And the answer is no, it's not. There's a 6 next to it, right? So whenever there's a 6, or there's a number next to it or anything around it, get rid of it. Same thing that we did with the emoji or the happy face. Let's do the same thing here. So cancel out the 6. For that, I need to divide this side by 6. That would cancel that out. Whatever I do to one side, I have to do it to the other side, so I have to divide this side by 6 as well. Now that I have the absolute value symbol by itself, so absolute value of x plus 1, then I can continue on solving the problem. 60 divided by 6 is 10. So now I have completed my first task, or the first step of getting the absolute value symbol by itself. Step 2 says, figure out if this equation is actually valid, meaning like, can it be solved? Can we take the absolute value of something and get a positive number? The answer is yes. So we can actually keep going. This is actually valid. We could actually solve this. So all we need to do now is split it up into 2 separate equations. One of them will be the positive version. The other one will be the negative version. Again, I'm not messing with the inside, so I'm going to leave this as x plus 1, but I'm going to set this equal to the positive version of 10. And I'm also going to set the equation x plus 1. I don't mess with the inside at all. And I'm going to set this equal to the negative version of 10, which is negative 10. Then I have to solve each one, and then you have your 2 answers to the absolute value equation. The rest you know how to do. So we draw the wall, solve for x, subtract 1 on both sides. In this case, I get x is equal to 9. On the right-hand side, same idea. Draw the wall, subtract 1 on both sides. I get x is equal to negative 11. So the 2 answers to the absolute value equations are x is equal to 9 and x is equal to negative 11. If you plug those 2 values back into the original equation, they will make the absolute value equation true. Okay, example number 3, moving right along. Same idea here. It looks crazy. Not that crazy, as long as you remember the steps. First thing we need to do is get the absolute value symbol by itself. Same thing that we did with the emoji. We got to do the same thing with the absolute value brackets. So first thing we do is draw the wall. What is in the way of the absolute value being by itself? We got to get rid of that 3. We got to get rid of the 15. Which one is furthest away? The 15 is furthest because it's not stuck next to the absolute value symbol of y minus 8. So first we need to subtract 15 on both sides. So we do that to this side, we do that to this side. That way our equation cannot look as mean as it's looking right now. So drop this down. 3 times the absolute value of y minus 8 is going to be equal to whatever this is. 21 minus 15 is equal to 6. So I'm going to leave that as equal to 6 on the right side. I still want to get rid of that 3 though. 3 is multiplied by the absolute value of y minus 8. In order for me to cancel that 3, I have to divide this side by 3. That would cancel it. But whatever I do to this side, I have to do it to the right side as well to keep the equations or the properties of equality intact. So everything else just drops down. So again, my absolute value symbol, that's the whole point, getting it by itself. So absolute value of y minus 8 is equal to 6 divided by 3 would give me the value of 2. So mission accomplished. We have the absolute value symbol by itself. Are we done? No, we still have to split it, right? So next thing we need to do is figure out if this equation is valid. So can I take the absolute value of something and get a positive number? Yes, I can. So I can keep on going. So the next thing we need to do is split it up, right? So let's break it up into the positive version and the negative version of the absolute value of y minus 8. So let's leave everything inside the equation by itself. So y minus 8, we're going to set that equal to positive, the positive version of 2, right? So this is what I'm leaving alone. And again, I'm messing with the outside. I'm not messing with the inside whatsoever. So now the next equation will say y minus 8 is going to be equal to the negative version of 2 or negative 2. Again, messing with the outside number, which is a 2, not messing with the equation at all. Now I got to solve it. Everything else you know how to do. So we're going to add 8 to this side, add 8 to this side. We're left with y is equal to 8 plus 2, which is 10. So there's my first answer. Same thing here. Draw the wall, add 8 to this side, add 8 to this side. Y is equal to negative 2 plus 8. That's going to change a little bit. That's going to be 8 minus 2, which is positive 6. Remember, when you have opposite signs, you have to subtract it. So there you go. You have your two answers. Remember, for absolute value equations, most of the time you're going to get two answers. So don't get stumped. Don't try to do just one and say that you're done, because that's not correct. You would only get half credit. Example 4. Solve the equation for the indicated variable. So in this case, we have something a lot crazier looking, but we're going to treat it the same way that we treated the emojis. So first thing we need to do, draw the wall. The whole point is getting the absolute value simple by itself. Don't get overwhelmed. Keep your eye on the price. So we want to get this alone. So the first thing we need to do to get that alone is move the 3. So that negative 3, we're going to add 3 to both sides. So let's do that. Everything else stays the same. So we're going to drop down to 1 over 2. 1 over 2 absolute value of x plus 5 is going to be equal to negative 13 plus 3, which is negative 10. Again, we're almost there, but we still have to get rid of that 1 over 2. Now, if I want to get rid of the fraction 1 over 2, I have to multiply by the multiplicative inverse, or the opposite of 1 over 2. The opposite of 1 over 2 is basically just 2. So if I multiply this side by 2, the 2 and the 2 would cancel. And I would just be left with 1 times the absolute value of x plus 5, which is just basically the absolute value of x plus 5. So I would basically be left with the absolute value of x plus 5 by itself, which is what I want. But the problem is, whatever I do to the left side, I have to do it also to the right side. So whatever I do here, I have to do it there. So that means that negative 10 times 2 on the right side will give me a negative 20. So there we go. We have the absolute value symbol by itself. Great. Step 2 says, make sure this equation is valid. And upon inspection, the absolute value of some stuff is giving you a negative number. Can you get into the shower and come out dirty? No, right? That doesn't make any sense. Like, how are you going to get into the shower and come out dirty? How's a number going to be inside of an absolute value symbol and be negative? So in this case, this is not valid. You cannot take the absolute value of something and get a negative number, which means only one thing, that there is no solution, which means you're done. There's no more work to be done. You just say no solution, call it a day, pack up your stuff. Well, actually, don't pack up your stuff. Finish your work. And then, yeah, so these examples will be in the case in which you have no solution. If there's any other questions, let me know. See you guys in the next one.